Good morning, everyone. Now we will discuss this topic about parallel circuits. We are finished with the series circuits, and now we will be discussing parallel circuits. So basically, parallel circuits is defined with a circuit having two elements, branches, or networks that are parallel if they have two common points or 2 points in common. Just like in this figure, we have here point A and point B, which are common to both element 1 and element 2. And then here for this figure, we have three lamps and they are connected in parallel since both here, this point here, and this point here are the same for all three lamps. And just like also here, and this, as you can see, this part here is connected to the positive side and this one here is connected to the negative side. So the basic idea of a parallel connection is that all components are connected across each other's leads. The defining characteristic of a parallel circuit is that all components are connected between the same set of electrically common points. So there are many ways no on how to draw a parallel circuit. So we have here in this A. Puwede siya nga ing-ani, horizontal ka-connect, puwede pod nga isa lang ihang source, kana siya ana. And puwede pod nga naka-diagonal, no? Kani mas maklaro gyud siya nga all points are common. Pero if ing-ani ang porma, since you can see no other element connecting between 1 and 2 at this point, just connecting wires, so parallel gyapon ang tawag nato ana. So there are many paths for electrons to flow, but only one voltage across all components. So a branch, no, is defined in a parallel circuit with the definition of having a path for electric current formed by one of the load components, such as resistor. So since we are still dealing with DC circuits, so our load here are usually represented with resistors. In this case, we have R1, R2, R3, and R4. And they are connected in parallel since these points here are common and these points here are common. Okay, so we will have this example. So first, determine the conductance and resistance of the network figure below. First, we have to define what conductance is. So conductance basically is the reciprocal of resistance. So here, conductance is very vital in solving the total impedance, or the total resistance of a parallel circuit, since for us to solve it, we will be using the concept of reciprocals. So here, we are given three resistors, 18 ohms, 9 ohms, and then 6 ohms. So first, we are going to um, get first the total conductance, which again is the reciprocal no, of your conductance. So that's 1 over 18 plus 1 over 9 plus 1 over 16. That's equal to 0.3333 Siemens. So the unit for conductance is either Siemens or ohms. That is SEI, MENS, or MOS, MHOS. So the total resistance then will be the reciprocal no, of the total conductance, which is 3 ohms. So basically, that's how we solve the total resistance of a parallel circuit. So if they are equal in value, so that is just equal to R over N, no? So the RT here represents the total resistance, and 1 over GT is equal to 1 over NG, which N here determines the number of parallel elements which have the same, no? Same value, since this should be equal resistors. So for us to get the total resistance, that will be just equal to R divided by N. So for example, if we have here a parallel network which has the same values, that is 18 kilo ohms, so we will just divide that value into how many elements are there. So basically, we have 3 elements that are in parallel, so the total resistance there will be just 6 kilo ohms. So voltage sources in parallel. So the voltage sources of different potential should never be connected in parallel. However, when two potential sources are connected in parallel, each source will deliver half of the required circuit current. So as you can see, no, um, it's very unusual to have two voltage sources connected in parallel. Usually, as you can see there sa inyong mga DC nga mga appliances like flashlight or DC gadgets, no? Since na kay polarity nga plus minus kasagara gina-series na nato ang mga voltage sources. If ever nga nakaparallel siya mahitabo ang total nga current will be divided no by the two voltages. So kung nakay current nga moagi dira and nakay current nga moagi dira, the total the total uh, the total current kani siya will be 2I. So ang isa ka I or half of the current will be coming from this element here and half of the current will be coming from this voltage source here. So for example, you have a 12-volt battery and a 6-volt battery, each having a internal resistance of 0.05, and they are inadvertently placed in parallel as shown in the figure below. Determine the current through the batteries. No, so same man siya sa ato mga examples previously no sa ato ang mga voltage sources which has internal resistance. So ang isa 12 volts, ang isa 6 volts, and they are having both 0.05 as internal resistance. So from Ohm's law, so let us go back sa atong Ohm's law, that is just equal to ET over RT. No? The total current will be equal to ET over RT. That is, ang total ng mga voltage will be 12 minus 6, since mas dako man ni siya, so ma-minus siya. So naa kay 12 minus 6, so that's around 6 volts. And your total impedance will be 0.05 and 0.05. So naa kay 60 amperes, no? Nga, sa tawagan na, nga total current. So tremendous currents will occur within the sources resulting in the possibility of a fire or explosion if naa kay duha ka voltage sources nga imong parallel. So delikado na siya. That's why most of the time ato na siyang gina-series, no? So these are the formula, no, on how to solve the current, the voltage, and resistances in parallel circuits. As you can see, the total voltage will be just the same with the voltage 1, voltage 2, and voltage 3. Depende kung pila ka bulk elements na sa imuha and sa inyong circuit. And then the total current will be the sum of the individual branches. And the total resistance will be the reciprocal of the sum of the reciprocals. And the power will be just the total power of each element. Components in parallel circuit share the same. So as a review, here you can see that components no in parallel are share the same voltage. They have the same voltage for any element no sa imong tawag ani sa imong parallel circuit, and then the total resistance in a parallel circuit is less than any of the individual resistances, and the total current in parallel is equal to the sum of the individual branch currents. So also here for parallel circuits, they have a certain relationship no between the current and the resistance. So the individual resistor currents are inversely proportional to to their respective magnitudes. So these are represented by these equations here. So you can see that Ix over Iy is equal to Ry over Rx. That is I1 over I2 will be equal to R2 over R1, since again, they are inversely not proportional with each other. So from there, we can get we can derive the current division theorem. So sometimes it is necessary to find the individual branch currents in a parallel circuit when only resistance and total current are known. When only two branches are involved, the current in one branch will be the same of the fraction of the IT. And the resistance in each circuit can be used to divide the total current into fractional currents in each branch. This process is known as current division. So, pwede nato siya i-represent with these equations. I1 is equal to IT multiplied by R2 over R1 plus R2. And the I2 is equal to IT multiplied by R1 over R1 plus R2. So, as you can see, baligid siya, no? So, kung I2 yung ginasolve, R1 ang naadire. Kung I1, R2 siya naadira. But again, take note ha, these equations are true for just two branches nga parallel circuit. If you have two or more, or if you have more branches, we will use this formula. So Ix will be equal to IT multiplied by RT over Rx. So the ratio of the total resistance to the individual's resistance is the same ratio as individual or branch current to the total current. This is known as the current divider formula, and it is shortcut method for determining branch currents in a parallel circuit when the total current is known. So for example, you are given here with R1 510, R2 270, and R3 to be equal to 430 ohms, and they are connected in parallel. The total current drawn by the circuit is 300 milliamperes. So what is the current through R3? So para ma-solve na to siya, we have to first get the total resistance. So again, the total resistance for a parallel circuit is the reciprocal of the sum of the reciprocals. So naa kay reciprocal sa R1, reciprocal sa R2, reciprocal sa R3. Imo siyang i-sum or imo siyang i-add, and then kuha mo ang reciprocal atong total. So that will become RT is equal to 125.16. So para makuha si RE3, so that's just IT multiplied by RT over R3. We know IT, we know RT, and we also know R3, which is 430 ohms. So that is 300 milliamperes multiplied by 125.16 ohms over 430 ohms. So you can get I3 to be equal to 87.32 milliamperes. So another example. We have three loads, but here they are connected in parallel and they have the same voltage, no, for all, since they are in parallel. So your total voltage will be the same as the individual voltages. So load A takes 9,200 watts or 9.2 kilowatts, no? So this is power. Load B takes a current of 60 amperes, and load C is a resistance of 4.6 ohms. As you can see, they are of different parameters, no? Load A is power, ang given. Load B, ang given is current. And then si load C, ang given is resistance. But we know, again, voltage. So, masolve nato na siya using Ohm's law, no? Sa ato mga previously solved nga mga formulas. So first, you have to calculate the resistance of load A and B, the total equivalent resistance, and the total current and the total power. Muna siya ang needed na ito ipang solve. So first ko na to si RA ug RB. So muna akong giingon kanina, since we have a derived formula naman para sa power, di ba? P is equal to V squared over R. So para ma-solve na siya, imuhang kuan RA, imo lang i-cross multiply, no? Si P, so imong divide whole equation by P and multiply the whole equation by RA. So RA will be equal to E squared over PA. So this 230 squared divided by 9,200. So na ako'y 5.75 na value sa akong RA. Si RB, just Ohm's law, V over I. So na ako'y 230 over 60, which is equal to 3.83. So again, please take note that E and V are used interchangeably sa ato ang DC nga circuit. So pwede na siya V, pwede na siya E. So your R equivalent will be again the sum of the reciprocals, and you have to get the reciprocal of that. So naa kay 1.53 ohms as your total, no, nga resistance. So your total current will be just the the total voltage multiplied by the total resistance, that is 1.53, no? Nga kuan value sa imong total resistance. So 230 volts divided by 1.53 ohms. So na kay total current nga 1.550 ohms. Pero pwede pod ano nga sa tawag ana, we will use Ohm's law para ma-solve ang ato ang IA ug IC. So si IA, since we are given with power, so P is equal to VI man or EI, di ba? So I is equal to P over E. So 9,200 divided by 230, so na ko'y 40 amperes. And then si IC, just Ohm's law, V over R, so that is 230 divided by 4.6, na 50 amperes. And we know, given man si IB nga 60, so 40 plus 50 plus sorry, 40 plus 60 plus 50 equals 150 amperes. So it should be the same, no? Pwede nga individual, imong kwaon, din mo siyang i-total, pwede po katong total voltage o total resistance imong gamiton para makuha imong total nga current. Same is true sa imong power. So sa imong power, total power is the sum no of individual power. So power ni A, power ni B, o power ni C. So si power ni A given 9,200 or 9.2 kilowatts. Power ni B will be just Ohm's law. So P is equal to EI. So na ako E 230, I is 60. So 230 times 60, natay value ana para sa imuhang power sa imuhang P. And para sa imuhang C, so power sa C will be just E squared over R. So 230 squared over 4.6. So your total power will be 34.5 kilowatts, no? Or that is 34,500 watts. Pwede po niya ang katong total power na lang ay total voltage o total current na lang imong gamiton. So your total voltage will be, or your total voltage, or since the same lang voltage at tanan, so 230 volts, and your total current is 150. So yung siya multiply, you can also get 34,500 watts or 34.5 kilowatts, no? So pwede individual yung pag-solve, pwede po siya nga katong total power o total current lang ato ang gamiton. Now, we will proceed sa atong series parallel circuits. So the series parallel circuits, these are circuits that contain both series and parallel combinations. It may be defined as a network in which some portions of the circuit have characteristics of a simple series circuit and other portions have the characteristics of a simple parallel circuit. So natay two types na atay series parallel circuit nga kung imo siyang i-simplify, it will result into a series circuit. Si parallel series circuit is kung ang imong circuit imong i-simplify mahimo siya nga parallel circuit. So for visual nga representation, so you can have here this example. So si R1, R2, R3, R4, and R5 are all resistances in this circuit. So makita nimo si R1 na diri, si R2, R3, and R4, they have this common point and common point here, common point here. So the R2, R3, and R4 are in parallel. So we immediately recognize that the resistors R2, R3, and R4 are in parallel. This parallel combination is in series with the resistors R1 and R5. So the total resistance may now be written as follows. So as you can see, naatay new nga figure or new nga kuan nga symbol diri. So R2 is in parallel with R3 and parallel with R4. So kanang two bars diha nag-represent na siya nga si R2 is in parallel with R3 and si is also in parallel with R4. So how do we get the total or equivalent resistance nato ani? So this is just the reciprocal of the reciprocals of this. So that is 1 over R2 plus 1 over R3 plus 1 over R4. So muna siya ato ang total equivalent nga resistance para sa kaniyang combination. So kung ima na siyang makombine, so meaning na kay total nga resistance, pwede na nimo represent into one single resistance, no? So pwede din tanga na ay R1 dire, then total equivalent resistance dire, and R5. So imong ending or imong result will be a single series circuit. So this is what we call a series parallel circuit. So these are the steps, no, on how to analyze a series parallel combination. First, reduce the original circuit into a single equivalent resistor, redrawing the circuit in each step of the reduction as simple series and simple parallel parts are reduced to single and equivalent resistors. Solve for the total resistance, solve for the total current, and determine the equivalent resistor voltage drops and branch currents at one stage at a time, working backwards to the original circuit configuration again. So example, consider the circuit no, in the figure below. So first, you are going to find RT, calculate I1, I2, and I3, and determine voltage V1 and V2. But we have to first identify no, kung unsa ni sila. So the RT is the total resistance no, sa imong R1, R2, and R3. Si I1, I2, and I3 are the currents nga gaagi sa imong circuit. So si I1 will be this current nga moagi diri, padulong dira, padulong dira. However, at this point, since Ang parallel naman nga agian natunga imo ang current na isa ka part mo agi diri, tapos isa ka part mo agi diri, no? So naa rin kay I2 and napod kay I3. And mobalik na pag-abot diri sap na pud sila and mobalik na pud din siya dira sa imong negative sa battery and balik na pud din siya dira. So nga na mahitabo, no? So kung parallel siya matunga ang imong current. That's why we have I1, I2 and I3. Now, the voltages. So si voltage 1 mo na siya ang voltage across your R1. Si voltage 2 mo na siya ang voltage across your R2 and R3. Ang pangutana nganong V2 lang siya, nganong walay V3. So we know that R2 and R3 are connected in parallel. So kung parallel sila, same ra imong voltage at this point, no, since nag-share man sila og common point, so voltage ani diri o voltage ani diri will be just the same. So muna ang V2 ra siya gi-represent. Isa na siya sa ato ang mga ipang-solve. So by examining the circuit, we see that resistors R2 and R3 are in parallel. This parallel combination is in series with resistor 1. So kung mo siyang i-parallel combination si R2 ug R3, so sa given ka nato 10 ug 40. So that is 1 over 10 1 over 10 plus 1 over 40 and kuha nimo ang reciprocal ana, no? So imong value ana will be 8 kilo ohms. So na ako'y 20 kilo ohms nga R1, na ay 12 kilo ohms nga R1 ug imong parallel combination ani nga 8 kilo ohms. So naa rin ko'y 20 kilo ohms nga total nga resistance. So total resistance will be R1 plus the parallel combination of R2 plus R3. So I can then get 20 kilo ohms. So from Ohm's law, your total current will be equal to 2.4 milliamperes, which is katong current nga moagi since naka-series naman sila, di ba? So same ra ang current kamo agi gikan diri padulong dira ana same na siya nga series nga current which is your IT. So kung tan-aw nimo sa figure ganina, si I1 will be just also the same sa imong IT. Kay again, if you can recall sa series, si IT is equal to R1. That is for a series circuit which is 2.4 ohms. So the current I1 will enter node B and then split between the resistors R2 and R3. This current divider may be simplified as shown in the partial circuit below. So mo ni siya. Kani siya nga point is mo ni siya ang nahitabo diri, di ba? Kabalo naman ko nga 2.4 ang moagi diri nga part sa imong circuit. So pag-abot diri matunga siya na isa diri na ipadulong pud dira. So muna ang imuhang i-solve na dayon karon. Si I2 moagi siya sa 10 kilo ohms, si I3 moagi kay 40 kilo ohms. So we know current divider, di ba? So si I2 will be equal to the total current multiplied by 40 kilo ohms divided by the total nga the sum of the resistances. 40 kilo ohms divided by 10 kilo ohms plus 40 kilo ohms. So nakoy 1.92. So nganong 40 kilo ohms atong gigamit dire? Since again sa ato ang current divider rule, ang katong yang opposite yung imong gi-consider kay inversely proportional man sila, di ba? So na ako'y 1.92 amperes dire, milliamperes dire, and para sa akong I 3.48 milliamperes. And then using the above currents and ohms law, we determine V1 is equal to 2.4 multiplied by 12 kilo ohms. So nakoy 28.8 volts. And then say V3, 0.48 milliamperes multiplied by 40 kilo ohms, which is equal to 19.2 volts, which is also equal sa imuhang V2. So that will be our example para sa ato ang series parallel nga circuit.